Hello, and welcome to a basic video introduction to SimWise FEA for ZW3D, Finite Element Analysis for ZW3D. In this video demonstration, we'll look at the basic steps involved in setting up and analyzing an FEA. That involves assigning proper material properties, proper loads and restraints, meshing the model, and then finally post-processing the results. We'll model a simple bracket being restrained at 2 bolt holes and the bottom cutout, and we'll apply a torque acting on the bearing hole. Here we are inside the SimWise FEA for ZW3D interface with a simple bracket part. We'll begin by defining the direction of gravity for the model. The direction is indicated by the cyan-colored arrow on the orientation indicator. We'll also specify the length units to be meters. Later on, when we define a torque, our units will be in Newton meters. Next, we'll define the material for the bracket. We can choose from a library of materials built directly into the program, or we can custom define our own materials. Next, we'll apply restraints. We'll begin by applying fixed restraints. Later, we'll change these restraints to be normal to their respective faces. Now we'll do a multi-select on all the restraints in the model and change the direction of the restraining degree of freedom. Next, we'll define the torque that will represent a shaft applying load on the bearing hole. We'll have to change the direction of this torque so it's acting about the proper axis. In this case, we'll choose the global reference frame and assign a torque of -50 Newton meters about the axis. Next, we'll mesh the part. Now we'll turn off the visibility of all restraints to make it easier for viewing the mesh and the final results. Now we'll solve the FE analysis. Now that the analysis is complete, we can use some of the tools inside ZW3D FEA to post-process and better understand our results. We can activate the clipping plane feature. This feature allows you to section a plane through the part, change the orientation or the position of it to allow you to get inside the body and see the stresses and the displacements internal to the part. Next, we'll look at the isosurface tool. This tool allows you to view internally through the part stresses above or below a specified value. We also have the ability to show the exaggerated deformed shape of the body. We can also animate this deformed shape. This is a helpful tool for understanding the overall deformation a part undergoes. Also note that if we wish to, we can also turn on the undeformed shape and overlay it transparently over the deformed shape. SimWise FEA for ZW3D also has powerful rendering and animation capabilities, capable of saving photorealistic images, as well as AVI movie files. Finally, we have the ability to export a simulation report. This report contains all the information that was required to set up the analysis, and it also contains the final results. Before we conclude this demonstration, it is important to note that SimWise FEA for ZW3D also models assemblies, allowing parts to interact with one another. This means that things such as weldments and bolted assemblies can be modeled when it is not possible to analyze a part just by itself. This concludes the basic demonstration of SimWise FEA for ZW3D by ZWSoft.